And then over here in the classroom, we can just look at the smartboard. All right, so what do we want to start with? Corresponding angles, alternate interior angles, alternate exterior angles, consecutive angles. What's the easiest one to spot? Anybody have a favorite angle relationship yet? Did we find any pink angles? Which angles are corresponding? Or we can do it the other way and just go in order. 4, 3. 4 and 3 are a linear pair. Okay, guys, we're working on this pair deck. Let's go in order because maybe that'll help. So 2 and 13. 2 and 13, what's their relationship? If this is the transversal, are they on the same side or are they alternate? Alternate. So are they inside these lines or outside these lines? So this one is inside. Let me make the other lines. So 2 and 13 are inside the blue lines and alternate of the pink lines. So this one is going to be alternate interior. So we're going to make that light blue. And then if I erase this, what about 4 and 11? 4 and 11, how is that different? 4 and 11. They are on the same side. So 4 and 11 are on the same side of this green transversal. And are they inside of the lines or are they outside the lines? Inside. So that's just going to be consecutive or same side. We talked about it being same side. And we won't do all of these. Anybody have one they want to do? We're going to 1 and 16 next. What are 1 and 16? 1 and 16 are a good pair to do. So we didn't talk about this yesterday. What if they're not connected? So if I live at 1 and I'm trying to go to my friend's house at 16, can I take one transversal to get there? I cannot. This is where it's no relationship. So this one is no relationship. If they are not connected, there's no transversal, there's no relationship that can be made. Okay? These only work if you're traveling on a transversal. So what about 8 and 11? 8 and 11. 8 and 11. We've got a transversal. This is how they're connected, right? Are they inside these lines or outside those lines? Inside. And are they alternate or same side? Alternate. So this is going to be alternate interior. So this guy's going to be blue as well. Okay. Did anybody find any corresponding? So we've got none. We've got the light blue, alternate interior. We've got same side, but we don't have alternate exterior and we don't have corresponding. So anybody find an alternate exterior or a corresponding? 1 and 3. So 1 and 3 are definitely corresponding. Now the trouble here is none of these are parallel. So 1 and 3, if they were truly corresponding, should be congruent. And that's kind of the trouble with this drawing is this is obtuse and this is acute. So 1 and 3 are definitely corresponding, but because the lines aren't parallel, they're not actually congruent. When the lines are parallel, they will be congruent. Anybody find, oh, I color-coded that wrong. So corresponding should be pink. I don't want anybody to get messed up here. So corresponding should be pink. What about alternate exterior? Do we have any alternate exteriors? Anybody find an alternate exterior? 5 and 7. 5 and 10. 5 and 10 are 100%. What color is that supposed to be? That's my yellow, right? So 5 is alternate from this transversal with 10, and they are outside of these lines. So 5 and 10 are on the outside, they're standing up on the curb, and they're alternate of the transversal. So 5 and 10 are going to be our alternate exterior angles. 3 and 15, 3 and 16 I can get with. So 3 and 16 are alternate exterior. 3 and 15 are going to be no relationship, and let me show you why. So if I've got this transversal, 3 and 15 are definitely alternate, but one is outside. So angle 3 is outside this line. Angle 15 is inside. So if I drive my truck through here, I'm going to run over 15 because it's inside, but 3 is standing on the curb safe. This one is no relationship. So 3 and 15 are no relationship. So our first no relationship was because they weren't even connected. Those are the easiest ones to spot. This one is super tricky because you almost want to make it corresponding. 3 and 11 would be corresponding, or 7 and 15 would be corresponding. And you almost want to make it alternate exterior, but 3 and 15 are exterior. 3 and 15 have no relationship. So I'm glad you brought that one up. Any other ones that kind of we want to talk about or look at? I don't really want to go over all of them, but we can if we need to. We're going to practice this more. You'll get better at it as we practice it. So let's go to slide 3, because a lot of people did some great stuff on slide 3, and this is going to be very similar to one of your homework questions. So if I look down here, somewhere up a little bit higher, I think I have some numbers, right? So if angle 1 is 65, let's talk through this. If angle 1 is 65, and I'm just going to put a blue circle here because my mouse is not being very fun today. What's vertical to angle 1? 3. So angle 3 is also going to be 65. What is corresponding to angle 1? Angle 5. So angle 5 is also going to be 65. What's vertical to angle 5? 7. So angle 7 is also going to be 65. All of those acute angles are going to be exactly the same. Sometimes I put little X's, and I should put an X in this one, in all the acute angles, right? Because then I can go back and I can make an O in all the obtuse angles. And all the obtuse angles are also going to be congruent because these lines are parallel. If this is 65, this blue angle, how can I figure out the pink angles? They are straight, they are supplementary, so the math is 180 minus 65. What is 180 minus 65? 115. 115. Nice. So all of these pink angles are going to be 115. Does that make sense? Easy enough? Okay. So let's look at slide 4. Slide 4 is going to be the same thing. What 4 angles are acute? Just shout them out. What 4 angles are acute? Somebody said 5.
1, 2, 4, 7.
2, 4, and 7. So what are all of those acute angles going to add up to? 5, or not add up to, going to equal 5, 2, 4, and 7. What are all of those going to equal if I know that angle 6 is 142? 38. How'd you get 38? 180 minus 142. Okay. So all of those pink angles, all of those acute angles are going to equal 38 because these make a linear pair. I've got 38 here. Wow, that's crazy looking. Let me see if my actual mouse will help. And then 142 over here. They make a linear pair. So, ooh, that's a crazy line. They make a linear pair. This obtuse angle and this acute angle should equal 180. And that is a 38 for those who are wondering what the hell that mashup, what the heck that mashup of things look like. You can tell I'm getting stressed out a little bit. Sorry, guys. Questions? Okay. What if they get a little crazy and we have extra lines? Does that make a difference? Is number 5 the acute angles or the obtuse angles? Acute. So which, oh, I lost my mouse. This is why I don't use it. I'm gonna have to start bringing in my home computer. This is making me insane. So if angle 5 is 82, what other angles are 82? 1? What corresponds to 5? If I slide, 8 is vertical for sure. So 8 is acute. What else? 6 for sure, because I can slide 5 onto 6. They're corresponding. What else? 7, because that's alternate interior to 5. 9, because that's vertical to 6. What else? 4. 4, because it's vertical to 7, corresponding to 5, and alternate exterior to 8. So all of those angles are going to equal 82 degrees. All of the obtuse angles are going to equal 98. Okay, so if you want to color code those with little dots, I would be encouraging of that. So all of these obtuse angles, and you can put little O's there to remind yourself they're obtuse. It's almost like playing tic-tac-toe. You put X's on acute angles and O's on obtuse angles. The one I really want to talk about, though, is number 4. Number 4 gets a little crazy, right? Oops. Where did number 4 go? So let's mark what we know. Angle 12 is 121. Angle 12 is 121. What other angle is 121? 7. Why is 7 121? Because it's vertical, absolutely. So vertical angles are always going to be congruent. So angle 7 is also 121. Anything else 121? Which one? 14. 14 looks acute to me. So I like the thought of sliding it over. We can only slide on transversals, right? So we can slide the blue angles up this way, but we can't slide them over this way. Okay. Can we calculate anything else in that intersection? Because they're linear pairs. What should 7 and 8 add up to be? 180. So if we know that 7 is 121, what's 8? If they should be supplementary, they should add up to 180. What's 120? What is it? 59. So both 8 and 11 are 59. 8 and 11 are 59. And I swear to you, if you're not here yet, it's okay. We're going to get you there. But we're just kind of talking through, and I look at these as like puzzles. So if you like puzzles, you're probably going to like these angle things. If you hate puzzles, you're going to be like, oh my God, Miss Doherty, please make it stop. It will stop eventually, but we've got to be able to look at some of these complicated pictures and just figure them out. Can I transfer or move this angle 8 anywhere up here in this intersection? If I slide angle 8, where does it correspond to? 3, absolutely. So that helps me out a little bit. So 3 is also 59. Any other angles in this intersection, 59? I like it. Yeah, why 4? It is vertical to 3. Excellent use of the vocabulary. Excellent, excellent, excellent. We're given some more information up here. So instead of stressing ourselves out, let's go look at that other information. I'm trying to get color. Come on. Maybe if I use it, it'll let me get another color. It's so bizarre. All right. So if I go to angle 6 and I make this 75, what other angle is 75? I think there's 3 of them. Angle 1 for sure, because 6 and 1 are vertical. They're on opposite sides. Oops, I'm starting to write angle 6, not 75 degrees. So the question is 14? What do we think? I think yes too, because I can slide 16. It's on the southeast side of the top angle, and I can slide it down here. So angle 14 is on the southeast side over here. So I've got 75. What else? There's one more angle that I can label green, 70. 9, why 9? Because it's vertical to 14, yes. You guys catch on so fast. And of course, all of these are degrees, right? So if I know 9 and 14 are 75, what are 10 and 13? How can I figure those out? I know this is 75, what's this one? I know this is 75, what's this one? And I'm looking in the chat too. 105, why 105? Absolutely, so the hidden math here is these make a straight. So 13 plus 14 equals 180, and 14 plus 10 equals 180. Each of those linear pairs, each of those pairs that make a straight add up to 180. So I can compare, and I can do 105 and 105. Now we're stuck with the tough ones. And there's a couple of different ways to get 2 and 5. Couple of different ways. One way is, if we look at 7, right, that's an obtuse angle. If I slide 7 up, which 2 angles does it cover? 2 and 1. So this whole angle should equal this whole angle. So angle 7 was 121. So this whole piece is 121, and this little green piece is 75. So if I know this piece is 75 and the whole thing is 121, what's the missing piece of angle 2? What is it? 46? Yeah.
I did it a different way.
How'd you do it?
I did 6, 5, and 4, like on the bottom house right there.
Uh-huh.
So I know it was going to equal 180.
Uh-huh.
So I added 6 and 4 together, because I knew 6 is 75 and 4 was.
Love it.
And, yeah.
And I think my computer is just lagging. Oh, there it is. It caught up. So what Dalton was saying in the classroom, and I'm trying to find a new color, is if I know that these 3 angles should add up to 180, and however you do it, you can add these 2 up and subtract them from 180, right? So lots of different ways. You can also do the triangle sum. Does anybody know how many degrees there are in a triangle, in all 3 corners of a triangle? Do you remember that from many years ago? All triangles add up to 180 degrees every single time. You can literally take a triangle on a piece of paper and tear off all the corners and put them all back together, and they'll make a straight line. And we'll do that eventually, maybe, if I can figure out a way to do it digitally. So if you know the pink angle at 8 and the green angle at 6, you can subtract those from 180, which is essentially what you did, the pink and the green, in order to get the missing one. We will definitely practice this more. We're not going to go on to slide 6 right now, because I think 2 and 6, what relationship do they have? 2 and 6. Oh, I do have a corresponding. 2 and 6 are 100% corresponding. So angle 2 and angle 6, we're going to mark corresponding. Is everybody with me where I am? So the task cards in today's folder, yesterday's folder. What about 3 and 16? How are they related? And we're just going to do like the first couple. 3. Alternate exterior, absolutely. Some people in my first block said, how do you know what's the transversal? So the transversal connects the angles, and then the parallel lines complete them. Okay. What about 6 and 11? Can I go from 6 to 11 in one straight line? So this is no relationship. Okay. We'll do a couple more and then I'll give you about 10 or 15 minutes to finish it. Angle 4 and angle 7. What's that relationship? Same side interior. Absolutely. Okay. Anybody have any that they want to go over before I let you loose? Let you practice? Okay. Question 3. The second one. 9 and 11. 9 and 11 are the hardest ones, I think, to spot. So 9 and 11 are connected by this transversal. Are they on the same side of the transversal or alternate sides of the transversal? They're on the same side of the transversal. This time the transversal is horizontal instead of vertical. So sometimes that messes people up. And then I've got 11 is inside of those parallel lines and 9 is outside of the parallel lines. So Nee, you're 100% right. I can take 9 and I can slide it over to 11. That makes them corresponding. It's the northwest or the northwest corner and the northwest corner. And those are the hardest ones. So this one is going to be corresponding. Any other questions? Yeah. Number 7. 4, 5, 6, 7. So 6 and 9. 6 and 9. And I'm on number 7. I'll zoom out a little bit. I've got a transversal here and parallel lines, right? Are they on the same side or are they alternate? Alternate for sure. And are they inside or outside the parallel lines? Inside. Because if I drive my truck through this street, it's going to hit the 9 and the 6. So those are alternate interior. Yeah? Anybody else? I'm taking requests. Want to work on one your own? Okay. Anybody know Anthony Brunswick? I'm a little worried about him. Andre's not here either. It's Friday.
First question on question 3.
Okay. Let's go look, because some of these are definitely, like, the struggle is real. Let me get my writing tool, though. All right. Ooh, that's big. So we said the first one on question 3. 4 and 6, or 4 and 10. So I've got 4 and I've got 10. First question, are they connected by a transversal? Can you go from corner 4 to corner 10 on a straight line? Then they have no relationship. Yeah. Question 2, number 2. So 3 and 8. 3 and 8. 3 and 8 are connected by the transversal here. They're alternate. One is interior and one is exterior. So this is no relationship. You guys are finding the hardest ones, right? It's tough because you're like, there can't be this many no relationships. But yeah, they really are. Did you have another one, Brendan? Number 4, 1, 2, 3, 4, A. This one? Question 3, number 4. Question 3, number 4. This one? 1 and 8. So 1 and 8. First thing you're going to do is connect them by a transversal. So they're on alternate sides of the transversal. And are they going to get run over by my truck, or are they safe on the curb? They're going to be safe. So these are alternate exterior. They're alternate at the purple line, but they're outside of the parallel line. So this one's going to be alternate exterior. And I see in the chat, number 4, question 2. So number 4, question 2, 14 and 15. 14 and 15. 14 and 15 are connected on this transversal. So they're on the same side. And they're inside those parallel lines. And I don't know if you can see me, but like my head is turning because I like the parallel lines to be horizontal and the transversals to be vertical. So sometimes I just reorient my head, right? When we get to some of these things, students literally take their Chromebooks and they're like, okay, no, I like to look at it this way. If you want to do that, go for it. Okay, that's not crazy at all. So this is same side interior. Okay. They're on the same side of the purple line. They're both on the south side of the street, but they're inside the parallel lines. So I'm going to run them over by my truck. What other ones do we want to talk about? Don't be shy. You guys are asking great questions. And this is a lot of information that I've been throwing at you in the last 2 weeks. Geometry should not be 4x4. You need like that day in between each geometry class to like absorb what you've learned. Four, 1, 13, and 16 are all exterior angles for sure. Yep. Yep. Those are all, and 6, 7, 10, and 11 are always going to be interior. So that's kind of another way to look at it. So for this question, 10 and 15, 10 is 100% interior. 15 could go either way depending on what the transversal is and how you're looking at it. So 10 and 15 are connected this way. I'm looking at it and I'm thinking these are interior of the parallel lines and they're alternate to the purple transversal. So these are going to be alternate interior angles. Alternate interior angles. I love that we're getting some dialogue going, guys. We got more questions, or are we ready to go solve some equations? I want everybody that has questions to have the opportunity. All right. Let's jump back to the digital note. Here we go. So if I know 79, what is this question mark? How big is that? And how do I know? It won't let me switch. Why won't it let me switch? There we go. Sorry, technical difficulties. So if I know this angle is 79, what's that question mark? I've got my transversal. My drawing's starting to get very cluttered. And I've got some parallel lines. What's this question mark right here? 79. How do I know that? They do. Alternate interior angles are going to be congruent. So you can make yourself a little note there. Alternate interior angles will always be congruent. So if this angle is 79, then this angle down here is going to be 79. They're alternate interior. They're both acute. So if you have two acute angles, they're going to be congruent as long as these lines are parallel, right? That's the trick, the caveat. What if I go down and I look at number 2? Here I've got some parallel lines and some parallel lines. But I have an acute angle where the question mark is and an obtuse angle where the 124 is. And I think there's a pink note underneath that. My computer is just being crazy slow. I'm not a very patient person, guys. You'll get to know me like that. And this just makes me want to throw computers out the window. Come on. It's like an old car, you got to talk to it. So I've got my acute angle up here and my angle down here. Acute plus obtuse is always going to equal 180 degrees. These are same side. One of the other things, like you do alliteration in English class, same side supplementary. So same side supplementary. They're always going to equal 180 degrees. You have one acute angle and one obtuse angle. So the invisible math here is going to be 180 minus 124 equals 56. Okay. The benefit of having a slow computer is you have lots of wait time. So what equation would I set up here with question, come on now, come on. Question number 3. If I have two obtuse angles in question number 3, because I'm pretty sure that's what I have, do I set them equal to each other or equal to 180? Still not looking at question 3 yet. Come on. Equal to each other. If I've got the same size angle, right, they're both obtuse or both acute, we're going to set them equal to each other. And if I could show you that, I would. It just doesn't even want to drag. And then it goes to a new page. This is fun. I think they spent $200,000 on these new computers for all the teachers, by the way, that I'm fighting with. It was a great use of money. All right, we finally got it. We finally got it. So this obtuse angle up here and this obtuse angle down here, we're going to set those equal to each other. So 11x equals 10x plus 9. And what does x equal? Have we all figured that out? We subtract 10x from both sides, we get x equals 9, right? So corresponding angles, they're going to be the same size. Corresponding angles are always going to be congruent. And then down here, we've got same side angles, right? So same side angles, same side supplementary, same side supplementary. You're going to add those together and set them equal to 180. Add those together and set them equal to 180. So let me see if I can. Oh, look at that, it's working. So excited. So what do we get when we do 11x plus 3 and 13x plus 9? It's like I'm writing in invisible ink. Oops, that's a 13x plus 9. We should take bets on how long it's going to take for all of that equation to appear. You think a minute? 35 seconds? Hey, look at that. And that's not an 18, that's a 13. So let me see if I can fix that. And this will take another 35 seconds in order to appear. There we go. So then we combine like terms, and we've got 24x plus 12 equals 180. And then you just continue to solve that from there. Has anybody already solved it? I'm going to pull out my calculator because my brain hurts today. 180 minus 12, and then divided by 24 gives me 7. Now, please remember, just like in our angle bisectors and our segment bisectors, once we've solved for x, I can always ask you to substitute it back in. So if I'm asking you this little acute angle here, you would do 11 times 7 plus 3. If I'm asking you the obtuse angle, it would be 13 times 7 plus 9. Okay? So you guys have seen me struggle. How about if we all go to slide 9, and I give you another 5 minutes or so to answer these 4 questions. So take about 5 minutes, answer these 4 questions on slide 9. Feel free to write it on your own paper. It's going to catch up eventually. There we go. So if you haven't already solved these 4 problems, try to solve them. Maybe you guys can zoom in better on your computer. Oh, there we go. That's how I wanted it to look. Hopefully you can read that. Have the picture, but I can't write on it. I love the discussion that's going on in here. Going to warm my screencast if I went. So what do we think? Should we talk about them? Okay. So what do we get for number 1? 38? Number 1? Am I on the wrong one? 85. Why is number 1 at 85? Are they vertical?
No, because I did. There's 85 out here. There's going to be 85 there.
Okay. Okay, absolutely. So we can go vertical and then corresponding, or we can just do alternate interior. Either way, right? But if this is acute and it is just barely acute, then this question mark down here is also going to be, and you can for sure do vertical and then corresponding or alternate interior. What about number 2? What's the answer to that one? That one's the 38. Why is this question mark for number 2 38? How'd you do that?
The inside has to be sort of 180. So 180 minus.
Absolutely. And that kind of looks like a U to me, or a C. So if they're inside and on the same side, so same side interior, they're going to add up to 180 degrees. How'd you set up this equation? Are these equal to each other or equal to 180? And number 3. Equal to 180 in number 3. So the 6x and the 12x minus 18 are going to have to be equal to each other. It's the same as this one. These 2 angles are same side interior. These 2 angles are same side interior. You've got one that's acute down here, the 12x minus 18, and one that's obtuse up here, which is, I think, 6x, right? So you're going to set those equal to each other, and you get 18x minus 18 equals 180. So x equals 11. Fantastic. And then down here, same thing. These 2 are supplementary. They're same side supplementary. So we're going to add these 2 and have them equal 180 as well. What did you get for number 4? Anybody? Throw it in the chat. Number 4, I got 25. Do we need to look at that one? Are we okay on that one? So we get 7x plus 5 equals 180, and then solve it from there. Okay. That is our digital notebook for the day. The remaining class time is yours to work. So let me go back up here. And if you have questions, chat me, yell it out if you're in the classroom, do whatever you need to do. But let me show you what we got going on. Maybe. Come on, little computer. You've got a couple of things between today and Monday. Okay, so if we're back in today's folder, day 2, we just did the, come on. We're not going to worry about this pear deck up here. We just did the task cards and we answered those questions. If you're stuck, please do D4, okay? We just did slides 7 and 8 on the digital notebook. This is what I'd like for you to do now. So there is a video of me doing the left problems through this entire slideshow. You've got a link to your own Google Slides right here, or you can just open this up and do it on paper. Doesn't matter to me. But in the video, you're going to see me doing this one. I think you get negative, I get -7. I want you to do the right problem on paper and see if you get the same answer. So we'll be doing different problems, but we should get the same answer, okay? And we just keep on going and keep on going until we get to the very end. So the last handful of slides, it gets a little more complicated. Note that all of these, you're either going to set the angles equal if they're the same kind of angle, or you're going to set them equal to 180 if you have one acute and one obtuse. Those are your only two options. They either equal each other or they equal 180. They do get kind of tricky towards the end. So round about slide 12, I think, or slide 13, they start having two variables. So you'll have an X and a Y. Make sure you watch the video all the way through so you know how to do those when you get to the X and the Y, because in addition to this homework that is assigned for tonight, you've got 4 discussion questions for Monday. So I want you to watch the video, do those practice problems. You'll have some time to do that now. Then there's like a 10-question homework right here. And then Monday's homework is the 4 discussion questions are from the questions from today, from the video you're just going to do right now. But basically, this Monday folder has these 4 discussion questions in it. And question 2 is in this video that I'm assigning you right now, okay? So all you're going to do is tell me what you get for X, and you're going to write it in the chat for me. Make sense? All right. It's time to practice. The next 15 minutes are yours, or 14 minutes until the bell rings. And then enjoy the weekend, guys. I hope it doesn't rain all weekend. I think it's supposed to rain on and off, yeah. Sunday looks good? Oh, I like that. I'll hold on to that for hope. And as always, guys, if you have questions, just let me know.